Python for Supply Chain Management, Introductory Concepts. In this brief lecture, I'm going to talk about why Python is important for supply chain management and also go over some very basic concepts that will help you get started with Python coding right away. So when we use Python for supply chain management, most of the time what we're doing is scripting. A script is a series of commands that you give to the computer so it can execute those commands one after the other without you having to be there. I mean, you could still be there, but it doesn't need you to be there. It's like an automation of a list of tasks. Think of it like a cooking recipe and the computer like a bot that can cook for you, but the bot the bot does not have very good cooking skills, so you have to give it detailed instructions. Once you give it a detailed recipe, you write it out and hand it over to the bot, then you can watch the bot or go away or do whatever, and the bot will execute those instructions one after the other and cook food for you. So scripting is a similar activity for computers. You can give the computers a series of commands. You don't give it a command until you run the command. You first write out the commands in a file, and then you tell the computer, okay, run all the commands in this file one after the other, and it would do that. Now, scripting is not programming. So the reason I'm talking about this is that I want you to feel confident that you can do it, because I know you can. This is not programming. You do not need to be a programmer. You do not need to be to write any complex code to use Python for supply chain management. You can do very powerful analysis and supply chain planning activities just by scripting with Python, which is you give a series of relatively simple, straightforward commands, and then the computer will do the task for you. So scripting, a little bit formally defined, is a series of commands or simple programming steps that perform a series of actions to achieve an intended goal. It is used to conduct analysis that is repeatable, verifiable, and easily modified. Why is it repeatable? You can just tell the computer to run the script again on new data, for example. Why is it verifiable? Anybody can read the script and see what commands you gave and what were the options that you used with those commands. Easily modified, you can just open up the script file and change the commands, change the order, change the parameters, things like that. Other than analysis, it is also used a lot to automate tasks. So for example, let's say you have a server which runs your favorite social media app. Let's say the server for Instagram. Now there may be a script running on the server that periodically backs up the storage to a remote location so that if the server crashes, your Instagram doesn't lose all of its data. So that'll be like a simple script. It would execute every hour or every 30 minutes or once a day, and it'll just run a command to compress and copy the files or a database to a remote location. Right, so that'll be an example of a script. So it's often used to automate tasks like backup, automate tasks like installation of software on servers, but we're not going to do any of that. We're just going to use it to do the kind of things that are useful to a supply chain manager, like analyzing data, forecasting for different products, inventory optimization, things like that. Now, scripting is much, much simpler than programming for a variety of reasons. Number one, you don't need to learn complex algorithms or come up with your own algorithms. All you're doing is just telling the computer to do a bunch of tasks in order, right? So the complexity of programming doesn't apply to scripting. Also, scripting languages tend to be very user-friendly, like their syntax is not that convoluted because you don't have to do very complex, million code lines type of coding projects in them. Often scripting files could be anywhere from 10 lines to maybe about 100 lines. Maybe, they might go in rare cases to thousands of lines, but really beyond that, whereas complex software today like Gmail, like Google Office, like Microsoft Office, they are in the millions of lines of code, like 20 million lines of code, 100 million lines of code, 8 million lines of code, like that, right? And so you're not approaching that scale at all. You're just going to write usually, 30 lines, 50 lines, 20 lines of relatively simple commands and be done. Okay, programming is, on the other hand, is writing detailed computer instructions, often with complex logic, complex algorithms, to develop a tool or an application that provides some useful functionality to the end user. Now, you're often writing scripts for yourself, although other people could potentially use them if you can set them up that way. But programming is you're writing it for users. Users have different requirements. They can use your program in different ways. So you have to factor all of that in. And often you have to do something really complex, because if it was that simple, users would just do it themselves by scripting it, right? So programs are often at a very different level of complexity and scale. So we're not going to do any programming. We're going to do some scripting, although these days all of that scripting or programming is just called coding. But the kind of coding we're doing is going to be the scripting kind, not the programming kind. Now, why should we do scripting? Why can't we just go into Excel and hack out some formulas? There are various advantages to scripting. Excel files are prone to errors. Errors that remain undetectable. Right? The only thing worse than an error is an error that you can't detect. Because it's very difficult to verify the analysis done in an Excel file, you can follow the sequence of formulas, but what if the analyst uses an add-in to run a regression file? Now, regression is usually not a formula in Excel. You go to data analysis, you click regression, and it runs some code in the background, gives you the output. There's no formula showing you what options were used to run the regression that you can trace. Right? So even if you are tracing through formulas, which is itself tedious and error prone and difficult to do, you could still not go all the way, because many steps in Excel, like pivot tables, don't leave a formula behind. And so it's very difficult to verify these steps and their sequence. Only the end result is visible to the Excel user, and some formulas can be traced through, but it is difficult, and not everything is a formula in Excel. In scripting, everything is a statement, a command, and they are listed in a text file. You can open the text file, see exactly which commands were executed, in which order. You can see what parameters and options were passed to those commands. So you can easily go through and see exactly what the analyst did in a script, versus it's very hard to do that with Excel. So if somebody wants to check your work, they could check your work with a script. Very hard to check your work with Excel. It's difficult to maintain an Excel analysis. Let's say your data increased. Now you have a new variable, and your formulas in Excel were not using that new variable, or the length of the data increased a lot, and your Excel model doesn't work anymore, so you have to redo the whole thing. In scripting, it's usually much more easier to handle changes in data formats, increase in data, an additional variable. That's usually very easy to do in scripting. Especially with the type of packages available which do a lot of heavy lifting for you, like for Python. So modifying and maintaining your script to handle changes over time is much more easier done with scripting than it is done with Excel. Then the other thing is, well, one thing is you maintain your analysis or script in Excel or scripting language. Another thing is somebody else. Like in companies, people go and come, right? You're working at a company this year, maybe you move to another company, and then the company which has all your Excel files, they hire somebody new, and this new person can't understand what you did and modify it for whatever the company needs today. So it's very hard to work with somebody else's Excel analysis. Whereas it's relatively easy to work with a script somebody else wrote and make changes to it, right? So if you think about maintainability or modifiability involving multiple people, where somebody writes the original script or does the original analysis, somebody else modifies or updates it, it's much easier in the scripting world than it is in Excel land. And fourth, which is not on the slide, but it is perhaps the most obvious reason that you should know, is that Excel is highly limited in the types of analysis it can do. Extremely limited to where we are with analytical tools today, which is why many companies, there's like this whole market of smart people that write Excel add-ons to do some particular analysis for a particular industry. Let's say for geological surveys, there's an add-in which can handle geological survey data or something, right? And then sell it to companies which do that stuff. Because so many managers are only taught Excel in management programs, that there's this whole need for the managerial class to get better tools, because Excel is very limited. And so there's a whole industry writing add-ins for Excel. Now those add-ins are expensive, they are proprietary, nobody else has looked at the code in them to make sure they are mistake-free. Some of those companies are small companies that write the add-ins. They may go, like the person retires or starts doing something else and the add-in is no longer updated. Excel comes up with a new version and your add-in can't be updated. There are people who use older versions of Excel because some custom third-party add-in they used was not updated when Excel was updated, right? So there's all these problems with Excel. It's limited, and even when you try to buy add-ins to increase its functionality, that has its own set of problems. Whereas scripting, often you can call libraries or packages which do certain things, and somebody has written a library or a package to do all sorts of things that you can think of, right? And so you can tap into all of that code, because scripting languages can often even call packages written in different languages. So, Python, for example, can call packages written in C or C++. They don't have to be written in Python. So somebody writes a library in C, somebody will write a wrapper for it in Python, and you can use that library written in C language in your script. You can use the functionality of that without having to be burdened by the complexity of that library or the coding behind it. And you have all that power. A whole universe of things you can do opens up to you, which is, it's like Excel is this tiny, tiny island. And then when you graduate to scripting, you can go anywhere in the whole world. So that's what it feels like. So, really these days, when you have tools like generative AI, like ChatGPT, Claude AI, other tools like that, which are very good at generating scripting type of code, there's really no excuse for managers not to get good at scripting, because you can basically just in English tell ChatGPT or Claude AI, what you want to achieve with your Python script, and they will generate a Python script for you, which 90% of the time just runs on the first try. And if there are errors and you go back to ChatGPT and say, hey, I'm running this error, it'll help you update the script as well. So with this AI technology available, it is very easy for people with all sorts of backgrounds without any programming knowledge to get into scripting and wake up to the vast world that exists outside of Excel. So hopefully you're excited now. So why Python? Why not some other scripting language? Well, Python syntax is designed to be clear and human readable. It's like Python code is just so easy to read. With other languages, you have to teach the languages technical jargon and technical terms, and it has these complicated keywords and some symbols or different types of brackets it uses. And a lot of times people get hung up on that initial difficulty. Well, Python is just almost, not exactly, but it's close to just reading English. It's like very readable. It was designed to be easy to read and understand and maintain the code, right? And it was designed as a scripting language. Python was initially created to be a really nice, useful, cool scripting language. So it's really well suited to people who want to do scripting, to have more, to be able to use their computer in a more powerful fashion. The second reason is Python has a huge ecosystem of libraries, perhaps one of the best ecosystems out there, especially to do with machine learning, data analysis, optimization, for multiple reasons. Number one, Python was written to easily use C libraries. And a lot of these libraries are written in the C programming language, which is one of the most popular programming languages. And so any library written in C with very little effort can be made ready to be used with Python. And so people have made that effort, and a lot of C libraries you can use with Python. In addition to that, because Python is easy to learn, a lot of researchers, analysts, consultants, this is the language of choice for them. And so there's a whole market. If you want to write a library that many people use, you want to make it Python accessible, even if it's not written in Python, so that Python people can use it, because there's so many people using Python around the world. So often very, very complex analysis can be performed with a simple one-line command in a Python script file, which is just crazy when you get the hang of it, because you get so much power using simple commands. And the third reason I picked Python is there's so much Python code out there, which means there's a lot of training data available for generative AI tools to train on. So ChatGPT, Claude AI, they all train on data that's out there. If there's a programming language where there's very little code that exists on the internet or out there on GitHub and other repositories, then the generative AI tool has little data to train on. So the generative AI tool like ChatGPT is not going to be very good at helping you code in that language because that is not popular and it didn't have a lot of training data to go on. Picking a popular language like Python means that ChatGPT, Claude AI, all these other models, Llama by Facebook, all these models, they have, been through like millions, tens of millions of lines of Python code. And so they really understand how to generate Python code well, these AI models. And so when you use AI tools to help you generate code, that code is more likely to be correct on the first try. And AI will do a better job explaining code because you can give it code and say, explain what this says to me. I don't understand it, and it'll explain it to you, right? So all of that just works really well with Python. Okay, so now I'm going to introduce a few simple concepts in Python and then show you how to jump right into a free Python environment by Google Online, where you can try out Python commands, where you can use it's integrated with AI tools to generate Python commands for you. It's gonna be awesome. So basically, to get started with Python, you only need to know the 4 concepts listed on this slide. Okay. Now, before we get into these concepts, just remember what is the main goal or work of computers or computing. The main goal or work of computers and computing is to process data and information, right? Structured information is kind of called data. Often computers work with, structured, even like free-flowing text is structured information because it's encoded in a certain character code and it can only have certain values or certain alphabets and so on and so forth, right? So computers are really good at moving data around, at manipulating data, at transforming data, at processing and computing data, right? So any scripting or code you do, it's going to be involved with, moving data around and manipulating data. So the very first concept that's very fundamental to scripting and coding and programming is what's called a variable. Variable, I'm guessing the term comes because, a variable is a box where you can put different things in it. So what's in it can change. Like I can have a box where I put in the number 2, and then later on I can update the 2 to a 3. Right? Maybe 2 was the number of customers in my shop. Third customer walks in, I update the value of this box to hold 3, like a counter variable, right? And so variables are just boxes in which you put data, okay? And just like when you pack, when you're moving homes, right? You get some large boxes, some boxes where you can put in which have a bar to hang hangers to hang your coats or dresses. So you can get smaller boxes for heavy stuff. You can get even smaller boxes for electronics with more padding, right? There are different types of boxes to put stuff in real life. Just like that in programming, there are different types of boxes. If usually, if you want, there are like 3 or 4 types that you'll see most of the time. One would be to store type of numbers, right? A box that stores numbers, any number you want to store. Then the second would be to store strings. Strings are basically text, right? So the data on this slide that you see is text, so you could store it in a string, a box which stores a string. Then the other types of boxes that you'll usually use will be collections of numbers and strings. So if you have a list of numbers, you can store it in an array or a list type of box, right? And so variables, we call them variables, but they're just boxes to store data, right? And that's how you can just think about them. A statement is a line of code that manipulates variables. And that manipulation could be by calling a function. And we'll talk about what a function is. But basically, when you manipulate variables, you have a statement. Okay, so let's say I have a counter variable, a box which stores the count of people that passed through, walked into Disneyland, for example. And every time a person walks in, I'll have a statement which will say, increment or increase the value in the box by 1. And so that'll be a statement. Statement is an action that is usually manipulating the data, which is the variables. Then a function is a series of statements that takes in certain inputs. Inputs are the data or the variables it needs or the boxes it needs to work upon, and then it does some manipulation on them, and then it spits out an output, which is the result of the computation, right? So for example, if you had to calculate the median of a list of numbers, right? And now usually it's just going to be a command to calculate the median in most scripting languages, or there'll be a package which you can call a command. But let's say you had to code the thing yourself. You had to code, you had to write statements to calculate the median. Now you may, if you write out the statements to calculate the median, like, sort the data, go to the middle of the data, pick the number to find the median, right? Type of that sort of statements. Now, you may need to calculate the median again later on, and so you'll have to copy paste these statements again and again, and we don't like copy pasting stuff all over the place. So what we can do is we can package a set of statements into what we call a function. We give them a name. So okay, these statements do a certain action that I want to do again in future, so I'm just going to give them a name and call them a function, and then whenever I want to do that action, I just call that function. So a function is like an ability that you give to your code. Okay, this is the ability that you have. You can do this work by taking these inputs and you spit out an output like a median calculation or a mean calculation or sum, right? And then because I've given you this name, you're a function, now I can call you at different places in my code, and you'll do the same thing for me again and again on whatever data I give you. So a function is just a set of statements that achieve a certain goal, and they're packaged together, given a name. And so you don't have to copy paste them, you just call their name whenever you want to use that action. Now, a set of functions can be packaged together and called a library or a package. Okay, both terms are used interchangeably. Packages, libraries, they're just like a set of functions. So somebody wrote a bunch of utility functions. Okay, maybe somebody wrote a package for statistics. So they wrote a function to calculate the sum, a function to calculate the mean, a function to calculate the median, a function to calculate the mode, a function to calculate standard deviation, a function to calculate p-values, a function to do a hypothesis test, a function to run regression. So somebody wrote all those functions, right? Then, they would put them together into a large box called a library or a package, and that is multiple things. One, you can reuse that. You can just import that library or package, which means bring it into your code by or tell your code to use that, point to it, and then call any of the functions in that library. The second thing the package and library do, which is very nice, is that the name of the function can be reused outside of that library. Now imagine you have a function called sum, okay? And in the numbers library, the sum function adds up numbers, okay? But you also have another library that deals with logarithms of numbers or some or angles, right? Angles on a circle. And you know that when you're going around a circle, your angle can be at most 360, then it goes back around the circle again, right? It goes back around. So maybe for this library which deals with circles, you want the sum function to sum the angles up to 360, but when you get to 360, you reset back to 0 because you've come around full circle. Right? So like, 400 is basically just 40 because it's 360 plus 40. You're back to the 40 place, right? So you could write a sum function that works with angles that resets after 360 in the circles library, okay? And then you could have a sum function in the numbers library. They could both be called sum, but the computer will not get confused because when you use the circles library, it'll use the circle sum function. When you use the numbers library, it'll use the number sum function, right? So libraries are really useful because the names within the library need to be unique, but some other library could use the same name. Like imagine a function called open file. Like you can imagine, a library that deals with images may have an open file function to open an image file. A library that deals with Excel files may also have an open file function that opens Excel files, right? And so otherwise everybody around the world would have to collaborate to use different names so their functions don't clash. But libraries, you can use whatever name you want and just put your code in a library, and then other people can use it without having to worry about name clashes and so on. So that's what library packages are, just sets of functions, right? Okay, so let's see some examples. Let's start with variables and statements. So this is actual Python code in this gray box here. See how nice it is. R equals 10. Right? Anybody, you go up to a fifth grader, say read this line, let's say R equals 10. Easy peasy to read, right? And then we say pi equals 3.14. Now the things in purple are variables or boxes. So R is a box in which I store the number 10. Pi is a second box, another box, in which I store the number 3.14. Area is a third box, another variable, a third variable. And in this, I store something that is based on the value of R and pi. So I take the value of pi, asterisk means multiplied by R. This should be R, not X. Multiplied by the radius twice, because the area of a circle is radius squared. Right, so area is a box, is a variable, and the value that's going to be stored in this box depends on the variable pi and the variable r. You multiply pi times r again, because pi r squared is the area of a circle, and so the area of this circle with radius 10 gets assigned to gets stored in the box called area. And then we have a different type of box called greeting, which holds a string, and the quotes are used to tell Python that we are talking about a string here. Because without quotes, Python would think, oh, hello is the name of another box, another variable. But quotes, we know these are not variable names coming up. Because see here, pi without quotes, Python knows pi here is not a string. It's not text. It's actually the name of a variable right here. Okay, so we want to make sure Python doesn't say, oh, there's no variable called hello, so we put it in these quotation marks. So this is a string, this is just data, this is not a variable name. So hello human is our data, and we store that data in a box called greeting. Now each of these 4 lines is a statement, because the simplest statement is an assignment statement. We just put a value in a box, assign a value to a variable. These are just the simplest programming statements. So that's how variables and statements look like. Right, it's pretty easy peasy lemon squeezy. People can read this and kind of figure out what is happening, but with a little bit of explanation, they're kind of pretty clear. Okay, this is what is happening. It's very readable English type of code with just some mathematical symbols for computations like assignment or asterisk for multiplication. There's no semicolons, commas, brackets, braces, parentheses, other things complicating our code. Now let's look at an example of a function. So I'm going to continue my color coding. Purple is going to be variables, and red is going to be function names. So up here, I define a function using the keyword def, and I give the name of a function, compute area. Then in parentheses, I specify what is the input data this function is going to work on. So the compute area function is going to work on 2 pieces of data, a width and a height. And then colon means this is where my function's code starts. Then I have to press tab to indent my text to the right, because if text is here, that would mean it's outside the function. But anything indented with a tab to the right to start one tab within def, or to the right of def, that will be statements that belong to this function compute area. So compute area has 2 statements. The first statement just takes width and height, multiplies them, and stores the value in a box called area. And the second statement returns that box. So return just means spit it out. That's the output of the function. Now defining this function does not execute these lines. It just tells Python, okay, this is a function I've defined. I'm going to use it later. Then you can go down later on and actually use the function in this way. So we have a box called W where we store the value 20, a box called H where we store the number 15. then we call compute area function like this, just the name of the function. In parentheses, we give it the inputs we want to pass. And equals means we assign the output of the function. What is the output? Whatever the return statement returns. The output of this function gets stored in this box called myArea. Okay. Now, you might think, oh, hold on, what's going on? We have WH down here, and we have width and height up here. That's because these are just labels. The compute area function takes two inputs. The first input within this function will be called width, and the second input will be called height, but outside compute area, I can call those inputs whatever I want. So here I'm calling them W and H. So Python knows that the first box I pass to this function will go to width. It will be called width when I'm in the function. And the second box I pass to this function, whatever I call it, I can call it X, H, I can call it ABC, I can call it Donald Duck, whatever I call the second box, that box will be called height within this function. Okay. Now, remember, or actually I forgot to mention, variable names cannot have spaces, and function names cannot have spaces. So oftentimes this underscore character is used, because if you didn't have underscore, just wrote compute area, it will look weird. It will look like one word, compute area. Right? You don't want to say compute area, it's compute area. So we can use the underscore instead of a space, because if you put a space, that gives an error. You can't have spaces in names of functions, and you can't have spaces in names of boxes or variables. So we can just use underscore to kind of separate the two words, compute area. My area has an underscore to separate the my from the area. Okay. So this is a simple Python function. Again, if it's looking a little bit weird, don't worry. You don't have to memorize anything. The AI will help you write the code. But you just need to understand that this function is defined with a def keyword. That means you're defining a function. Colon means anything after the colon, which is indented to the right with a tab key, belongs to that function. Anything within parentheses are the inputs. The boxes passed to the function to process. The function will do some processing and return an output with a return keyword. Any function that returns an output with a return keyword, you can use it like this. You can have an equal sign and use the function on the right hand side, and the results of the function will be assigned to whatever box you specify on the left hand side, in this case myArea. Now let's talk about, so we talked about variables, statements. See, all of these are statements. Every line of code is like a statement, right? So all these lines are statements, all these lines are statements. Let's talk about Python libraries or packages, okay? We're going to be doing this a lot because most of our scripting is just going to be calling functions somebody else wrote that do something useful for us. So we don't have to write them, we just use them. So to use other people's functions or libraries, we use the import keyword. So for example, in Python, there's a math library that provides some mathematical functionality, and I can use that by telling Python I want to use the math library. So I say import math. Now after I say import math, I can use anything in the math library. One thing in the math library is the constant called pi. So for example, I can write a statement called print, and in parentheses, this print is a function. So I'm calling a function here, just like I called compute area up here. So just like I called compute area and then I assigned the output of compute area with an equal sign and put it into myArea, here print does not return something, but I'm going to call print just like I called compute area with inputs passed in parentheses. So to print, I pass in math.py. This means look in the library or package called math. You'll find a constant pi. The dot means within math library. So math.py means the constant pi, which lives within the math library. Pass on that constant to the print function, and I'll just print out for you the value of pi. Notice this green statement. This is a special statement that just looks like English because it is. Because any statement which starts with this hash symbol is called a comment. Comments in script files are just English language comments that you put there for your future self or somebody else who reads your script so they know what your intentions are. So if you're going to do something complicated or something that's not conventional, you put a comment to explain, hey, I'm doing this because of this reason. Because if you return to your code, 6 months down the line, you may have forgotten, hey, what was I doing there? What was I thinking, right? And the comment will tell you, oh, this is what you're trying to accomplish, right? Or somebody else reads your script file, right? So comments are not for the computer. So the computer is just going to ignore any line with this hash symbol that starts with this hash symbol. That's just going to be comment for humans. That's going to be ignored by the computer. Okay, so computer's just going to skip over this print the constant pi line because it's a comment and go here and print this constant. Now notice that we imported another library called random, but here we did something different. We did import random as R&D. Now this is a trick we'll use often because library names can be long, like random is like 6 letters. So if you didn't, you can ignore as R&D, you can eliminate it. Let's say we eliminated as R&D, we didn't type it out, we just did import random. Then just like math.py, whenever you have to use something within the random library, you're going to have to write random dot. So there's a function in the random called randint, which returns a random integer. So if you want to call that function, you have to write random.randint. Okay. Then let's say you have to call another function. You might call it like random.uniform random or random.normal distribution, whatever you want to call. You'll have to say random dot. And if the name of the library is long, well, random is 6 characters, is not that long. But you can imagine typing that again and again and again can get very cumbersome, right? So computers are very good. They'll let us rename most things. And so as renames the library random for your script file only. So when I do import random as R&D, then the library called random is going to be known as R&D for my script, not for somebody else in the other part of the world, just for my script. I can use R&D as a shortcut way to refer to the library random. So now I can call things within random, instead of saying random dot, like I'm saying math dot, I'll just do R&D dot. So right here in this statement, R&D dot is going to get translated as random dot because R&D is just another alias for random, another name for random, for my script file only. So we often do that, often you'll see people do import pandas as PD. Pandas is a library to manipulate data, very popular, and people don't want to keep writing pandas.sort, pandas.merge, pandas.this, pandas.that, right? They get tired of typing pandas all day long. So they often do import pandas as PD, and they just do then pd.sort, pd.merge, pd.this, pd.that, right? Typing PD is a lot faster than typing pandas. So I want to show you this because it's just so common that you want to know how to do this, right? So here we're doing R&D dot to call randint function within the library random. We're giving it 2 inputs, the number 1 and the number 10. And what those are the minimum and maximum values for random numbers. So randint is going to give you a random number between 1 and 10. Whatever number it returns is going to get assigned to this box called random number, random underscore number. Okay. So this is a box I defined, and that's going to store the output of this function randint. Now I can print it. Okay. And this is again a very useful trick that you're going to see all over the place, printing with the F shortcut. Okay. So you call print, and in the parentheses, we're passing it a string. Remember back here, hello human in quotes, that's a string. So this is a special string where you put F before the quote. You say F, quotation marks, then you type your string, quotation marks, close. What F does it allows you to put the data stored in your variables into the string. So this string is going to be, let's say randint returns, let's say randint returns the number 6. Okay. Then this string is going to become random number is colon, and now this whole part, curly braces and the name of the variable within it, will get replaced by the value of the variable. So this variable stores the number 6, so it gets 6. Okay, so this is what f does. What f does it goes through the string looking for these curly braces. Okay, looking for these curly braces. When it finds these curly braces, f knows that the curly braces within them would have a name of a variable. So what f does it replaces this whole thing with the value stored inside that variable. Variables are just boxes that store values. So this whole thing here is going to get deleted, and in its place f is going to pop in the value stored in the box called random number. So what's going to get printed on the screen is random number is 6. Okay. So if that's not clear, don't worry, you get used to this. This is just a way we would like to print variables with labels, because what we can do is with the f shortcut, this f keyword, we can specify, sometimes we call them templates, right? Right? Sometimes we call them templates because random number is colon and then dash. This is a template, and this dash part gets filled in with whatever value stored in the random number box, right? Okay, and so that's how you can import libraries, call functions somebody else wrote in those libraries and benefit from them, store their output in your own boxes, and then print those boxes out. Okay, so now you can do scripting in Python. It was that easy, right? Now, where do we go? You can't just, start typing these commands on your computer. You have to go to a Python environment, a place where Python is understood to write your script to do this work. Okay, so I'm going to show you this beautiful place, okay, called colab.research.google.com. Okay, you can just take this URL and paste it, okay, and it will open up something like this if you're signed into Gmail. If not, it'll tell you to sign into Gmail or a Google login. Once you're signed into the Google login, it'll show you the recent Python work you've done. This may be blank. If this is the first time you're doing it, you can just hit plus new notebook, and it'll open a new notebook for you. And this notebook is where you write your Python code. Now, the notebook is made up of blocks. This is what we call a coding block, with a plus sign to run the code. There's no code, so just running it does kind of nothing, right? But you can add more blocks. You can do another coding block, and what's nice about this is you can add text blocks. So I'm going to delete the first coding block by clicking it and clicking this trash can icon, and I'm going to start with a text block. Text block is just where you write whatever you want in Markdown. So if I want to give a heading in this text, you can double click to edit. I can just do this heading. This is a heading that gives the title of my Python script. This is a subheading just to show you what you can do. So the hash in this Markdown box is a heading. See, this is what it looks like. And the double hash in the Markdown box is a subheading, and then a triple hash is a subheading type of thing, so smaller heading. Okay, and inside the code block, remember hash is comments. This is a comment, and I can just print hello human, and that's my Python code. So in your code blocks, this hash just gives a comment. This is a line that's computer will ignore, just for you. And then inside these Markdown blocks, you have these headings that are also defined by these hash blocks. When you go out of the text block, it does all the formatting for you. When you double click it, you edit it in Markdown mode. So if you don't know what Markdown is, you can just Google Markdown documents. They're just a way to add some formatting to text. But that's it. And see, if you run this code, it prints hello human. Voila, you're doing Python coding. You don't have to do any setup. Just go to this link, colab.research.google.com, and you start coding in Python. You can go to File and save this Python file and give it a name. IPYNB is the extension of this file. And when you give it a name, it's going to store it inside your Google Drive for whatever Google account you're signed into. And it's going to create a folder Okay. File save will save your Python notebook to your Google Drive inside a folder called Colab Notebooks. So once you hit file and save, and then when you go to your Google Drive for whatever Google account you're signed into, when you open this link, you'll find a folder there called Colab Notebooks, and inside will be this notebook saved right there. So you can open it again and continue your work. Now notice when you go to a code block, and you can always add more code or text blocks. Even if you go here at the bottom of a block, you can add another text block or another code block. Okay, so it will show you this link, start coding or generate with the AI. So let's do this. We're going to ask AI to do something for us. Now you can just tell in English what you want the code to do, and it'll do it. So let's say you want to do this. So say, okay, I write Python code to read in an Excel file called myexceldata.xlsx. This is the file name in this file, and make sure to read in the worksheet called sheet 1. You want to read in sheet 1, and assign it to a variable called myData. So just write in English what you want the code to do, press enter, and here you go. It wrote code that reads in this Excel file. Look, it's so easy. Okay, you import pandas as PD. You import the library pandas as PD, and then you just call the function read Excel. That's a function which lies in the PD library. You say PD.read Excel and give it the name of the file and the sheet name, and it reads the file into myData. Now there's a lot of error handling stuff. That's try except stuff that it added. So we're going to tell it, do not add try except blocks. Do not do any error handling. This basically, if the file doesn't exist, it wants to give you a cleaner error than the default Python error. That's just niceties. We're going to ignore that. And it's just simple code. See, just one line to read in an Excel file. Now, if you run this code, it's going to give an error because this file does not exist, right? If you go to files, this is where your files lie. This files button, there's no file here. If you did have a file, actually, let's create a file quickly. Okay. Let's call it column A, something B, hi means hello, 5 means 10, okay? And then if you save that Excel file, okay, let me just save it to desktop. Okay. Now, if you drag the file here, it will actually open this and work. Okay. So let me drag the file. Here. Okay. And I have to rename the file to book1, because that's what my file is called, so book1. So read in the file book1.xls, and the sheet name is sheet1. Let's just double check the sheet name. Yeah, that is called sheet1, right? And you can change it. Let's change it and try something else. Call it, data. Let's call it data, okay? Okay, so I have to upload the file again, so I have to delete this file. Because I changed the file, I called it data, and now I can change the sheet name to be data. This sheet name here is the name of the input, and equals data is the value you're assigning to that input of this read Excel function. Now we can also type print myData to print the data after we read, and run this command. And here you go, it read in your Excel data. Right, easy peasy, lemon squeezy. Okay, now let's put in another code block. Okay, and let's tell the AI, okay, write some Python code to generate 2 columns of random numbers and then make a line plot from those columns of numbers. Let's see if we can make a line plot. Okay, so notice it's using the random, it's using a NumPy library. NumPy is NP, and NumPy has a random function, so it's using that to generate column 1, column 2, and then it's doing this matplot library to plot it. So let's run the code to see if it works, right? Here we go. We plotted 2 lines of random data, 2 line plots, okay? So it's really easy with AI to do work here. Now notice that whenever you go and open a notebook here, it generates a virtual machine for you with a good amount of RAM, 12.1 GB of RAM, 107 GB of disk space. So it's running a Linux virtual machine in the background for you, right? And if you want more memory and more space, you can pay Google a little bit and run very powerful, access very powerful computers just through this web page, right? But because the virtual machine gets destroyed when I close this tab, if I come back and open this file again, this file would be gone, okay? So this file would not persist. So you can do this. You can mount your Google Drive, okay, and then you can store the book 1 in your Google Drive, and then if you close it, you know, the file would live in your Google Drive, right? And so it would not have any problems. You can read it again. However, files that are on Google Drive, you have to add /content drive my drive, and then, you know, if it's at the root folder of your Google Drive, you'll do it like this. My drive is your Google Drive, and if it's, let's say, within a data folder, you'll do data/this. So you have to change this path. And it's very easy. You can just use AI again. So we can just change this prompt. Circle my Excel file called, you know, book1.xlx. From my Google Drive, and the file is in a folder called data, right? And so let's run this command. So it generated this code for you, mounting your Google Drive and loading the file content drive my drive. Inside my drive is your Google Drive's main area, and then inside your Google Drive you have a data folder, and then you have a book 1 file, and then you can read in the file. And this would work even if you close it and reopen it, because your Google Drive stays your Google Drive, but this file here is temporary storage. It will get deleted, right? So that's where I would just recommend putting your data in your Google Drive folder, the same Google account you used to sign into this website, and then you can use the AI to write cool Python code, and you can understand the code, right? You can see what it's doing. So for example, here, you can go to AI tools and explain code. And it's going to explain you what it does. Importing libraries. So import matplotlib. This line imports the pyplot module from the matplotlib library. Gives it the shorter name PLT, just like we talked about. You can rename stuff, so you don't have to type in pyplot all the time. Generating random data. You know, here you're using this function to set the seed, which is, you know, not that essential, but yeah. You know, you have to understand something about how computers generate random numbers to understand the seed issue, which I'm not going to explain here because that's not the purpose of this video. But, you know, it explains you what the code does line by line in detail. So you can understand the code, you can write your code, you can run your code, you can load your data to Google Drive, you can read your data, you can analyze your data, you can go ballistic with this tool, right? And imagine you can do this from a Google Chromebook, like a $200, you know, inexpensive, low-powered Google Chromebook can still do this because the code doesn't run on your laptop. It runs on this virtual machine on the Google servers. And if you are not happy with the performance, you can pay a little bit and get GPUs and commercially great type of powerful virtual machines running your code, right? Although, you know, just the free basic one is good enough for most people, right? So for free, you're paying a single penny. You have 20 GB of storage for your data on Google Drive, and you have this free Python environment to do your coding. This is just amazing, right? So hopefully this was a good introduction to help you get started. And obviously, the more you use it, the more you use AI to generate code, then use this AI button. to explain code, the more you understand how the code works, and the better you will get at this.